Hi, this is Tim Lindquist, and this is SER 321 Principles of Distributed Software Systems. Today I'd like to talk about MVC, Model View Controller, and JavaSwing. And this is Unit 9. So here's the detailed schedule page. There are a couple of reading references. There's nothing in the textbook that covers this. There's a tutorial on Swing, and then we're going to go through a couple of examples. The Java part, actually, we went through in Unit 8, the C++ part from the GUI demo and also from the media player. So this unit is aimed at getting you ready to do the last assignment, which is to create a Java client for the C++ media library RPC server. For the mechanics of the distributed part of that part of it, there's an example in the calculator of Java client for the calculator RPC, JSON RPC. So you should use that as a way to start your solution for connecting Java to the RPC server. You have to you can reuse the proxy code that's there. There's no proxy generator, automatic proxy generator for Java, so you have to use an HTTP request object, and there's a sample of the program in there that does that, sample Java, which does that for you and connects to the calculator JSON RPC server. So you just modify it so that it connects to the media library server. And then so as a part of the last assignment, you'll also be developing a Java server that uses TCP/IP to download a media file. And that media file will go into a special folder, client folder, from the server. So it'll be from the Raspberry Pi to your Linux box. And it'll go into a special folder there, call it temp.mp3 or temp.mp4, and then play it from that folder. So in fact, you have the ability to download media files from the server to the client, as well as to access the server's information about the media library. So that's all described in this lab exercise, Java Media Client with Java Download Server. So let's talk about MVC in a little more detail. Last time we went through the C++ example, and I pointed out where the GUI class, GUI class, the class name ends in GUI, Media Client GUI, is actually the view. And from our perspective, the media client, which receives the callbacks from all the user actions on the GUI, is the controller. And then we use the servers, in this case both servers, for the last assignment as the as the model. So just as a quick introduction to MVC, here's the, actually you can tell I like Wikipedia. It's like a one-page introduction to MVC. Talks about its history. I'm not going to say much about that, but I do want to look at the graph that they have, or the diagram that they have, as well as talk about the different components. So in this case, we have a user and a view. So the user interacts directly with the view, and in our case, the user doesn't actually use the controller. There's a connection line between the view and the controller. Where, for example, a button click or a menu item selection in the view causes a method to be called in the controller, and the controller actually does all of the communication with the model. So this line doesn't exist either. The updates line, it doesn't actually update the view. The updates to the view are all taken care of by the controller. So there's a manipulates here, which is actually to query and exchange. In the case of 6, The model actually has two different components. It's the download server. You can consider that to be part of the model. And it's also the library, media library, JSON RPC server. Okay, so controller can send commands to the model to update the model state. It can also send commands to its associated view. Now they don't show that, but they describe it here. If I can get it to, there we go. It can also send commands to its associated view to change the view's presentation of the model. So that's exactly what a view does. It presents, it's the presentation of the model, and the control is kind of like the business logic. The model is the underlying data, so maybe very commonly in most applications it's some form of a database. So the model stores data that is retrieved according to commands from the controller and displayed in the view. And the view generates an output presentation to the user based upon changes in the model. So the view in our case consists of all of, in the last assignment, all of the JavaSwing controls that are available, and all the ones that we use. And in the case of assignment number 5, or in C++, the view is made up of all of the objects of those classes, the button class, the tree class, the input class, FLTK, classes. So those objects make up the view for us, and they're placed on a window. So it's very common to use MVC in web applications. We're not actually doing a web application, but nevertheless, MVC is certainly a very pertinent model, pertinent pattern to what we're doing this semester. So there's also a chapter in this open book, Wikibooks, and I thought I'd point you to that as well. And this chapter, let's see if I can boost it a little, describes MVC in more detail. It's actually a very good description of it, and you might want to go through it as well. Let's see if there was, I think there were a couple of points I wanted to. Longer description of what the model and the view is, and the controller. Nope, I thought there was a diagram here as well. So I'll refer you to that as well. And then the next thing is JavaSwing. So for JavaSwing, there's a tutorial as part of the Java tutorial that covers Swing, and it's actually very good. There are some examples here. So getting started with Swing, this is Oracle's Java tutorial. This tutorial has been around, almost around as long as Java has, and it keeps getting updated, and it's a very good reference. For several aspects. Well, I think it covers all of the built-in API. So it has it goes through a straightforward example and kind of explains JavaSwing for you. And then the other thing I want to make sure that you are aware of, I want to go back to the home page, and under the resources, under Java, we've looked at this before, but the API documentation, Java SE API documentation, and JavaX, not Java, but JavaX.swing. There are several sub-packages within Swing, but most of the components are covered in the Swing package. And in particular, all of the components begin with J. So a JApplet, a JButton, a JCheckbox, and a JCombo box. So we use a JCombo box. And here's the class, the Java doc for the combo box. And we also use a JText field, several JText fields. So the combo box is the drop-down list. So that within that combo box class reference, you will find methods that allow you to add new things, remove things from the drop-down to find out the selected. And there's also a way to identify an event handler when the selection in a combo box changes. And the text field is the R. There's several text fields. For example, entering information about the artist or displaying information about the artist is done in a text field. The same thing for the other string components as well. So those are the primary components of the UI. And we'll take a look at the UI in just a minute. And then JTree. And you can see there's lots of different aspects of JTree. JTree is actually the most complex of the UI components that we're going to be using. I'll try and show you two examples and read through quite a bit of it. JTree actually uses an underlying model, meaning that there's an underlying data structure that the JTree uses. We're just going to use the JDK provides default implementations, but you're free to extend those if you want to keep additional information. So that model is an underlying data structure that reflects the tree itself. So it can be much more complex than simply the data that's displayed in the tree. So if you want to, in the underlying model, you can associate with each of the different nodes in the tree a more complex data structure that may contain other information that you need to have about the particular node in the tree. For our purposes, because of the level of interaction that the level of interaction that we're assuming is feasible between the media library RPC server and the client, it really isn't necessary to do that. So if we need to get additional information about a given media description, we actually just go to the server and get it from the server, where it may be more common to store that information in an extended class of what's called default mutable tree. But that's all right, not a problem. This is, of course, about distributed computing, and we want to have as much network traffic as we can between our server and our client. So I wanted to again point out and remind you that you will probably need to use methods that aren't in the examples, and those methods you'll probably find in the Java docs for the appropriate components. All right, so let's go and take a look at the examples. And I think since I'm on a different machine, we're just going to download these things again. And I forgot, yeah, good. I've already got that one there, but I'm going to overwrite it. There's just maybe an old version there. And also the media player web. So we looked at these in the last unit, but we looked at the C++ versions of them, or C++ programs within them. This time we're going to take a look at the Java components of them. So now let's get to that directory. And let me extract both of them. So in the GUI demo, again, we've already looked at this before. It's got a C++ component. On the Java side, there are two different programs, and those programs are a folder browser GUI. So there's our view class, and then a folder browser. So a folder browser extends folder browser GUI, and it handles all of the events that are triggered by the UI components in the folder browser GUI. So the folder browser then is our controller, and the folder browser GUI is the view. So this one is a folder browser, and let's just go ahead and execute it. And let's see if this part works. That's the command for invoking it after it's been built. And this one has a command line argument, which is any accessible folder on the file system. And I think it defaults to the current directory. We'll find out. Yep, dot. So in this one, we end up with a tree. That tree is built based upon doing a directory of whatever the folder is you pass in as the argument. So this is a folder browser. It's a little bit like a My Computer, I guess, would be the right way to describe it. This uses a sort of swing, a JTree component is the left panel over here, and then what you see on the right is the rendering of whatever I choose on the left side. And I've got it set so that it will look at text files, a limited set of file extensions that are actually text files. So for example, Java is one of the things that it recognizes. So when I click on a file name on the tree, actually what happens is it displays, it looks to see if it's a file extension that it knows about, and if it does, then it loads the contents of that file into the right hand side. And I don't know of any way to there's no everything built into it to increase the font size, so you're just going to have to play with it on your own machine. And what are the different kinds of things that it recognizes? Well, it also recognizes an XML. And in addition to that, I can have it, so there's the current directory. If I go to my, I can enter a new folder in the J text field on the top panel, and then click Show Folder, and it'll redraw the tree based upon all of the files that are in that folder. So I'm not sure it went to home instead of, why it went to /home instead of home Lindquist. No, it did go to, yeah. Why it went to, yeah, the home Lindquist should have been the root for it, and there it is. So I won't recognize bash rc, but no, not docs either. It does text files. So you can see the different files that I have stored on my home directory on this Linux box, and in particular there should be SCR321 down here someplace. I'm not sure why it's not ordered, and I'm also not sure why I'm not seeing 321. There it is. Yeah, it's really small. So here are the examples. So I've got a subdirectory for sockets and so forth. So it shows you the different files that are available. So let's take a look at how at the code and how this tree gets built. The font size is a little bit too small to do much more with the user interface itself. So let's first look at the GUI. So this is the view. And in Swing, it is very common. The equivalent of extending a window in FLTK is to extend a JFrame. JFrame is, pardon me, the base class for a window, and it has all of the methods and all of the fields. Most of them are private, that will actually provide the overhead for displaying a windowed user interface or a windowed app. So folder browser GUI. I use this, you should have seen this by now, a static Boolean to tell me whether or not to print out debug messages. So this says print out all debug messages since it's set to true. And there's a debug method that checks to see if this is true or false. And if it's true, it prints out diagnostic messages. So you can see, again, the same idiom that we used for C++. I have protected fields in the Java view class to allow the controller access to them. JTree, you'll see that this is a very common thing. So of course I'm most familiar with mobile applications in both Android and iOS. Although the connections to the controller are a little different than what they are than what I'm showing you. This is very typical for a windowed application as opposed to a mobile application. Nevertheless, it's the exact same thing. There in iOS, it's called an IB outlet that in fact are accessible from the controller. And there's a little bit different mechanism to do it in Android, but it still provides the ability to access the view components. And you'll also find that in doing native mobile applications, that MVC is actually the basis for both of those platforms, both Android and iOS. It's all about MVC. Anyway, so we've got a JEditor pane, and that is the right-hand side of our folder browser. That's the pane where we display the text. The source code I've showed you are an XML file, and then a protected string path to root. That is a path name that gets manipulated by a couple of different methods. The JText field, the folder text field, so that control or that object will be the text field up at the very top of the panel, and then our button, display button, so that's the show folder button. And then we have some private, a JSplit pane. So this is a split pane allowing me to do either a horizontal or a vertical split, where I can have two different panes within a split pane, and I can control where the split actually occurs, set it by default, allow the user to move it wherever they want to, and so forth. Actually a very nice control. And then I also have this thing, default mutable tree node. And a default mutable tree node is something that I can attach to a J tree. So this tree, all of the different nodes within the tree are default mutable tree nodes. And a default mutable tree node has within it a list of default mutable tree nodes which make up its children. So as an example, there is a default mutable tree node for sockets. And that default mutable tree node has a list of subnodes. In this case, simple Java simple sock .jar is one of the default mutable tree nodes that's in sockets list of children. Simple interop.jar and meta-inf and so forth, right? So these are all default mutable tree nodes which make up the children. And then in the case of Java simple sock, you can see there's other subnodes within it as well. So that's the mechanism by which a tree gets built, is by adding or removing, by creating default mutable tree nodes, and then adding them to the child list or removing them from a child list of a given node. So there's a way to get hold of the root of a tree, and then we simply go through and create default mutable tree nodes, add those tree nodes or remove those tree nodes, and in this code you'll see the mechanism for doing that. The only thing that's a little bit tricky is that in order to get a hold of the root, instead of going to the J tree itself, you actually have to ask the J tree for its underlying model, and you get the root from that model. And then in fact, it's all, well, the root is a default mutable tree node, and we do all of our accessing through that default mutable tree node. So let's go ahead and read a little bit more of this. Here's the constructor for it. It takes a string path, which is the folder that is first to be displayed here. It actually sets things up, and you see that there is a method show tree from path, and what that does is go and remove everything from the tree, and then recreate the tree by using the facility in the Java API to get all of the files within a folder, and to get their simple name as well as their absolute name. We're just using their simple name there. So let's here's right below it is show tree from a path, and you can see here's our file. So we create a file which is the path. And we get the name of that file, and that's going to go in the root node. Path to root. Let's see. Oh, I'm sorry. Before doing that, before building it, I clear the tree, which means just delete all of the nodes out of this J tree. There's a method, an internal method here. You can reuse it because it'll be very handy. The best way So let's suppose that you have to take care of the functionality. Your user just did an add to the media library, added a new song to the media library. You've got to redo the tree in order to do that, right? You've got to add a node into the tree. Well, instead of searching for the node in the tree, the simplest thing to do, not the most efficient thing to do, but the simplest thing to do, you don't get graded, there's no points off for doing it this way. The simplest thing to do is to just clear the entire tree and then go and rebuild the tree. And when you rebuild the tree, this method, use the same method if you want to, show tree from. Actually, you'll have to change that, but it goes and builds default mutable tree nodes and attaches them to the tree. You can redo that method so that it contacts your media library to find out the names that are going to go into the tree, and then actually where you need to collect or get from the server the media descriptions to help build the tree. Very similar to the process that you had to go through in order to get the tree populated for the C++ version. So this code actually provides that for you. And there's the clear tree method. So here you can see, for example, the tree model. We're using it, so, as I mentioned, Java provides default classes for each of these things, expecting that you're either going to extend this class or there's, in many cases, an interface that's defined and you can implement that interface. It's best, the easiest thing is to extend an existing class. If you have to override some of the methods, that's fine, but generally the thing to do is to extend the class by adding new properties and then making those a property, setting the values of those properties before you put in the node. So these things are both clearing the tree and adding nodes to the tree. You can see that in order to remove a node from a tree, model.remove node from parent, remove the next node from its parent. So in fact, instead of listing who the parent is and calling a method on the parent that says remove one of your children, you actually tell the model that you want to remove a node from its parent, and you tell that method which node you want removed. So it actually uses the model in order to find, in this case, next, and then takes next out of its parent's child list. So what this thing does is just go through all of the subs of the root and removes that. Right. So get child model.get child is next, and then removes that from its parent. And let's see. In terms of building the tree, actually, you might want to use either this one or the next example that we're going to look at. So the main method ought to be in here as well. Oh no, I'm sorry, the main method is in, let's move to it, folderbrowser.java. And here's the main method. All it does is to create a new folder browser object, and it uses path. So path is by default the current directory, and if there's a command line argument, then path gets whatever that command line argument is. No validation checking, unapologetically, not very robust code. So let's go to the constructor of folder browser, because there's some stuff in there that will help you understand a little bit better how Swing works. Super if path is actually calling the parent, which is the folder browser GUI, and then tree add selection listener of this. So this says that when a node in the tree gets selected, it should generate a tree selection event, and it calls the method defined in the interface tree selection listener. And tree selection listener, right? So this is telling tree is the protected JTree component, JTree field of folder browser GUI. Tree is the protected JTree field of the folder browser GUI. So when the folder browser, super of path, executes its constructor, it creates a new JTree object. So when I reference tree from the folder browser constructor here, its parent's constructor has already executed, and now I am telling that tree that's already been created, I want to add a selection listener. So in fact, the callback is right here, value changed method. So if you look up in the Java docs, tree selection listener, you will find that it defines a method called value changed. So for my folder browser to implement tree selection listener, I must implement a value changed method that takes as argument a tree selection event. And it takes care of what to do. It's the control, what to do when the user clicks on a given tree component, right? When the user clicks on a given tree node. So the wire up is that one called the wire up says that I want to listen, I being the folder browser, I want to listen to selection events on the J tree and call back. So what you see down below is the bottom half of this exact same file, folder browser. Call the value change method whenever the user clicks on a tree node. And what it does is to get the default mutable tree node of the last path component. So that is getting the default. So if I select build.xml, there is a path from build.xml to Java simple sock, to sockets, to examples, to SER321. That makes up the entire path within the tree. So e.getPath would give me that entire path, and get the last path component in that will just get me the build.xml. So I get a default mutable tree node, which represents the very last component or the last segment of that selected tree item, and that's my node. Now I check to see if that node has text, which is a .txt, a .h, a .xml, a .cpp, .java. In other words, is this something that I can display over on the right-hand side? If it is, then in fact the rest of the code here goes and gets that file and loads it into, actually it doesn't get it, it just tells this control that it's to load that particular file, and it does that by means of a path name. And here it is, a file, uses the file URL. You can load this. This is the same thing we looked at with the browser, the simple browser. I can load it with a file which says go to the local file system and pick up that file and load it into that control. So display URL is the method that actually takes care of that for me. Okay, so there's probably, let's see, there's no, yeah, the button. I got to talk about the button. So that takes care of this in the constructor. This takes care of the wire up for tree selections. And to handle what happens when the Windows close button is selected, I create a window adapter. And the window adapter, the only one that it implements is the window closing event. And in that case, I just want to exit from my application. So this add window listener of WL is this new window listener. So that takes care of a handler, the controller event of clicking the X out of the window. And then the other listener that needs to be created is the button click. So display but is the button object in the GUI, in the view. And when I say add action listener, it says call me back, and action listener interface requires me to implement the action perform method. So when the button gets clicked, action perform gets executed. And here's my code in action performed. It actually calls the show tree from. All right, so it picks up the text that's in the text field. All right, so what I have highlighted in yellow goes to this component and picks up its current text value. It's a JText field, and get text on the folder text field. All right, so this text, it's now highlighting home, but that JText field is defined or declared and initialized in the GUI, and it's called a folder TF. It is a protected element of it, so I can get its text value. I can actually set its text value as well if I want to put something in here under program control. And then I call the show tree from to actually use that path as a way to rewrite this tree or to rebuild the tree. Okay, leave it at that. Now let's go to the media player. And so I downloaded the media player from this link, media player WebJar, on unit number 9 in the detailed schedule, and I've just extracted it, and I'm now in that directory, and it tells me I can do a build Java, and after I've done build Java, I think actually last time we found that this is a problem, but let's copy it anyway. So there it's been successfully compiled, although there was a warning, and now if I paste, and if I remember correctly, instead of it be called sample media app, it's sample media client. And this gives me a client that you can use for your media client for assignment number 6. And again, the same thing as with the C++, you'll have to add a file name text field somewhere in it. But other than that, it works, and it shows you how each of these different components are created in the tree, and it also shows you accessing these guys, each of these different text fields, as well as the combo box, the J combo box for selecting whether you want video or music. So the scenario is your user would enter a value as the title, a value as the album, the genre, and the artist, as well as a file name, and then select media add to cause it to be added to the media library. So your application would take that information, create a media description, call your media library JSON RPC server, and tell it to add that new media description. Then after doing that, your application would redraw the tree based upon the new state of the media library, which would cause it to be added into the appropriate spot within the tree. And this also shows for doing playback. Obviously, it doesn't download. These files are part of it, and I think actually in the last unit we looked at this as well. So here's a video. This uses Java FX, and in order to play it, I'll show you the code here in just a minute. But in order to play either a music or either play an MP3 or an MP4, you simply call a method in the view class and pass it 2 pieces of information. And let's go ahead and take a look at that. that come from? So this is the controller, and I'll just read enough of it to show you how to do the play and show you the constructor. So again, the controller extends the view. All right, so sample media client is the controller, and media library GUI is the view. Notice the same thing as with the folder browser, the exact same three. Oh, actually, I don't know if we did tree will expand listener. And I'm not sure there's anything in the application you need to do with tree expander, tree will contract, or tree will, I forgot what the other one is. There is action listener, which is to take care of menu item selections, and tree selection listener, which is to take care of node selections in the J tree. So the sample media client constructor takes care of doing the wire-ups, meaning that making sure that for every menu item selection that occurs, so if I do an add, if the user selects add or selects remove, where is it? Should be here. All right, so you can see when one of the tree items gets selected, that it gets printed out, and when a menu item gets selected, it indicates which one got selected. So you can see removing node labeled video, removing node labeled music. We'll have to take a look and see what's being printed out there. So the wire up to make sure that each of the menu item selections causes a method within the controller to be called is done by going through a two-dimensional array. And that two-dimensional array is called user menu items. It is defined in the media client GUI, media library GUI class. And I don't give you the source code for the class, but I do give you a Java doc for that class. And that Java doc should be in here, but it's not. It is in, let's go back to this guy review. It's actually in the documents directory. So let me just go ahead and file. And I just navigate the way down to it. This is in FLTK GUI and the media player. You'll see that there's a doc directory in there, and it has the Java docs for both the C++ classes and the Java classes. And if you open up index.html, this is the Java docs for media library GUI. So there's media library GUI, and if you look at the fields, you find the protected fields. There is a JText field called Elblum JTF, and that JText field, where's my browser? How did that go away? There it is. So the emblem JTF is this Java text field in the upper right-hand corner. And the author JTF is the artist, all right? So that's this text field. And then there is a set of file menu names, the genre text field. So this gives you all of the different fields that are available. And in particular, right now we're talking about this thing called menu item names. So let's take a look at it. The menu item names is an array of arrays. Note that the order of this array matches the order in the menu names array. What this amounts to is the J menu items for the first component. In this case, it has two different arrays. There's an array that represents the file and an array that represents media. So if we work through both dimensions of the array, or all the dimensions of the array, and all of the components within the second dimension, and do add action listener, that actually causes a action listener to be added for each of the menu items that exist in the GUI. All right, so this is doing, you should actually copy this code directly into your constructor, and it will cause the action perform method, which is down here someplace, the action perform method to be called anytime the user selects one of the menu items. So action performed, you can see here if it's an exit action, if it's a restore, if it's a play action, and so forth. The same thing for the tree selections as well, and those methods are right up above. So let's take a look at the play because it's probably the only thing that's really different from the way the folder browser works. And in this case, there is a method defined in the GUI, Media Library GUI. If you look at the methods, there is a method called play media, public method to play media file. The play media method causes a new thread to be created. You don't have to worry about how it does it. It just does it to play the media. Playing the media file checks to see whether an existing playback is already active. So if you hit the play button twice and call this method twice successively, it'll take care of getting rid of the disposing of the previous playback, and it should create a new one. The thread's an object of the internal. So the path, actually this is, should be better described. The path is actually a URL, a file URL, and the title is the title of the media file. So create a URL path or URI path, file : / get the current directory, and then the two possible things to play back in this example are an MP3 called Swan Song, and then the Machu Picchu video MP4. All right, so depending upon whether or not video or music has been selected in the Java, the J combo box, it's either going to play an MP3 or an MP4. You obviously have to change this code so that it plays, so that it downloads from your server and plays back the appropriately downloaded file. But you can see it creates a URI path, and then it passes that URI path to the play media method. That play media method is the one whose Java doc we just looked at, and it is actually in the parent, implemented in the GUI and the view, and then the node label is the title, and the title is just used as part of the display in the UI. So when I do media play, let's select music and do media play. That caused the action perform method to be called, and in this case it should have, I'm not sure what happened, it should have started playing this Swan Song MP3. So tell me why you didn't do that. Do that and select music and media play. There we go. And you can definitely hear that. So let's stop that. Okay, the selection of the play menu item caused action perform to be called in the controller, and within that action perform method, it checked to see if the command was play, which is the label on the menu item, and if it was, then in fact it found the name of the title. Actually, it's not even going to play that name of the title. In this case, it's just going to see whether or not I've selected a music or a video over here in the JCombo box. And if it's a music, it's going to play this MP3 file, and if it's a video, it's going to play that MP4 file. Right. So these files are actually provided in the. Let's get rid of this thing. As you can see in the project, the media player project, there is both an MP3 file, the Swan Song by Paper Navy, and the Machu Picchu time-lapse video that I got from Vimeo. So both of those are hardwired in there, and of course you'll be downloading from your Java server an MP3 or an MP4, depending upon which media has been selected and whether it's a well, actually you go and get its media description based upon the title, and then you download based upon the file name that you get from the media description. Um, okay, so I'm going to leave it at that for today. Again, we've been looking at unit number 9, Java UI with Swing, and talking a little bit about the Java Media Client and Swing. Again, the best way to do your solution to um, program number 6 is to use the media player web.jar, use its Java program as the basis for it, and there is a controller, a sample controller in here. Just sorry about that. I'll end with in the live directory. There is a media GUI.jar, jar tvf, live media GUI.jar. These are a bunch of class files. So instead of giving you the source code for the GUI, the media library GUI, what I've done is to compile all of that. There's the class file for it. And then there are other internal classes that are used within it. So instead of making the source code even more complex than it is, all you need to do is to include this media GUI.jar. You do not have to extract it. You do not have to extract this jar file. The build.xml includes this jar file as part of the class path. So you can create your client to extend this media library GUI class and use all of the controls within it in the exact same way as the controller source code, sample media client.java, which is contained in this exact same media player sample project. Okay, let's leave it at that for today. And next time we'll be talking about runtime environments, which is the lead-in to doing threading.